Okay, my friends, in a second we're going to go through some of these, and I'm going to talk about the DNA test and show you some blood samples and all that. But before I do, I want to show you, I've been having, oh, how do you get blood out of rocks? Show me you can do that. Well, I'll show you. All right. As you can see, I have all these same looking rock like that right there. All right, so once again, here's that rock. And we're talking about blood in rocks. Well, that rock just happens to be this rock. There's blood gushing out of this thing everywhere. That's a lung. I have a lung right here myself. Mine is in better shape than that. That was still in the water. Here's the key. If they linger in the water virtually forever, when they take them out, this came out of salty mud flat. And it was submerged in the mud, and he just saw a piece sticking out of it, which I think he saw something like this here, and he said, ooh, what's that? And he took it out, and here it was. Now, this is saturated, and what happens is when they come out of these conditions, almost immediately they turn into dust, and I can prove that as well. Now mine, this one here, is another lung, only this one was outside of the mud flat. So what happened is this one got boiled in this hot water flood, which Velikovsky talks about. And every culture on Earth said that Venus, which was a fiery comet Venus, almost hit Earth, and when it did, it combusted the skies, caused boiling rain, the oceans even boiled, and all of the animals cooked. Now, some of them settled in mud, and they just stayed in the mud. I have some of those too. And that's why I call them mud fossils. But then I started finding them just above the ground, completely, totally perfect. Only one flat side. Because they were just laying on the ground like this. And all the stuff ran away because they were up elevated. And that's where my condition is here. Where I am in very, very unusual conditions. There's a goose. Caesar Augustus. There's his feathers, and there's the flat spot, and everything I have follows the same pattern. Now, let's finish up with Gary. This is from Gary Evans over in England. Let's look at Gary's other shots. So at this point, he opens it up pretty good, and there's what it is. Now, within, I think it was a week, maybe 2 weeks, totally shot. Now you see that? I have other ones that are completely, totally, all of these evacuated down to where the main cavities are. There's still blood in there a little bit, but it's eroded because it was in a different condition. And then I have, of course, as I showed you, this one is just virtually flawless. Then I have another one here that I'll show you in a second, that all of this, which is the coating, what they call a pleura, has gone away, and we're down into the lobes of the lung, which is the alveoli. I'll show you that in a second. But my point is that just because it's a lung doesn't mean that it's preserved in the same way. It doesn't mean it's the same kind of stone. Some stones turn to basalt, some turn to sandstone, some turn to mud and clays, which this is, and I'll show you. See that? I think this was after 2 weeks, he said. It just turned into dust. And the same thing this would have done if it had come out of salt. Salt is the key. It's a destroyer. It's a bond breaker. It makes everything turn back into dust. Okay, my friends, this is going to be fun. We are going to go into geology, but really what geology was before it became geology. It was biology. There's 3 different feet. All right, they're all right foot. And I can tell you why, because of the fibula. This one you can see the toes in a little bit. We're going to get into them deep in a second. But I have the giants, I have all that stuff. All have been DNA tested. And I'm going to tell you right now, I have not had one single question from any university whatsoever, or archaeologist whatsoever. And I have reached out to virtually all of them that have made statements about this and that, and Denisovians, and all these different long-headed people, and they're talking about everything. They refuse to even comment on what I'm showing, and what I'm showing has been DNA tested and CAT scanned and certified in every single way. All right, I had several things DNA tested. This I had DNA tested. I extracted the samples. I extracted the samples from the 36-inch hand too. This is the fingertip, one little fingertip from that hand. And there was also a giant fingertip, which is 3 feet long. I'll show you these pictures in a second. And I sent them off, these 3 things, to be tested. And they tested them. It was done very well. And this was 7 years ago now. And it was the first in the world to be done on ancient DNA, basically, and ancient DNA humans, absolutely. And they looking for the mitochondrial DNA. All that means is it was a human. I don't think you can tell any special person or anything about it. All I wanted to know was, are these extractions human blood? And I mean, they came out literally bloody. And it just says it here. It says the PCR products are submitted to Eaton Biolab for DNA sequencing. Primers are used to generate the products. We're also using the excellent quality DNA sequence was obtained from the 36-inch sample and the lung. This one didn't have as good high quality, but it was this. I mean, first of all, you can tell. There's no question. And I had this DNA, CAT scan, and that's where the bone is and everything. This is a thumb. This is a right thumb because the bone is on the left-hand side, and that's the pads of the, and that's where the apical tuft is. And I have so much of this hand, it's amazing. I have the palm and everything, and that's where the apical tuft is. There's a bunch of stuff eroded more than some of the stuff. Anyway, that's that from that hand. Now, we're going to be going through all this stuff. And again, I have all this. Anybody can test it. If you want to test it, test it. I'm not going to do it again. This was not cheap. And I wanted it done, and I wanted it done right, and it was done right, and it was certified by the lab director of Helix Biolabs. Now, he did contact me because he was being assaulted, and he said, make sure that you tell everybody that you were the one that took the extractions. He said, what you sent me, we had tested, 100% certain of the results. But don't say that he extracted them. I extracted them. I didn't send him these giant fingertips and things. I sent him the extraction. I mean, I know what I'm doing. It came out perfect. And you can see blood comes out of these. I can get blood out of here in a second. Out of virtually any of these. Let me show you something else. That's the giant fingertip, 36 inches long. And I had to break off a piece of the grip skin, which is the friction skin, the tough stuff, to get down into the blood. That's the fingernail. That's the pad in the back. That's the blood supplies, vein and artery. See that's the piece I broke off. It's just this type of stuff. There's just no blood in there to speak of. I had to go down in here, and it's saturated with blood. And that's what came out excellent quality. And then, of course, I had this done. This is just raw blood coming out of the bottom. Now, something else I want to make a note of. You see that little strap that runs over there? All right? They all have locks on the fabric that coats them, just like this bone. You see this bone? I don't know if you can see that seam there. And there's another seam right there. Hold on. Excuse me. You maybe can see that better. And maybe you can't. I don't know. But they all have a seam where the fabric literally locks together. And I call that the spur lock. All right, what I was just talking about is the spur lock right there. And that latches a chunk of meat for somewhere, or your lungs, or your heart, or your kidneys, and it latches it to the rest of what's called your interstitium. This is a bone I have here. Well, not a bone. It's a chunk of meat. And that's where the spur lock is right there. This is when it first came out of the ground. And they all have that. They all have that to anchor their body part in position. That little flap. You see how cool that is? I mean, if you could throw that on a grill. All right, and this is what it looks like in a living tissue. All right, this is when it first came out of the ground. This is the lung right here. And again, that's the spurlock. That little strap right there. You see that strap? That holds it in position. And then there was one at the top, too, that came out of here. That holds it so that it doesn't go crazy. The entrance to it is all down here, all on the side, all the tubes come in. But it has to be held in position in your body, otherwise it'll flop around and bang into your kidneys or who knows what it would do. Now, the same thing with your bones. Your bones are locked in too. You see that foot? That right there was a bone. All right, and these are the locks that lock this in. Everything it's absolutely phenomenal what you can look at and see if you open your eyes and look at what's in front of you. Not only that, this still had blood in it. Even though it looks like it's just a chunk of quartzite, sandstone, whatever you want to call it. Look at this. In the back, right there, you see that? That's where the blood supply came down. It's been sitting in my shop 10 years. That's blood supply coming down. The two bones, you're going to have a hard time seeing them until I shadow them correctly because it's just so, well, maybe you can see it here. Maybe you can't. Hold on, let me back it out here. Hold on, let me get the light in the right way. But you can see the toes and all that stuff were in here, and they slant to the side. I don't know why. Tissues has the same thing. And the bone, one bone is back here, I'll show you, and the other one is up here somewhere. Right there, I think it is. It's hard to make these things out until you shadow them the right way. Shadows are the coolest thing going on because then you can really see what the structure was like. You see how I put this in the shadows? That bone was back in here somewhere. And this is the side it was laying on. Flat. See, it's flat. And this is actually got some, you see that layering there? That was the leather of the guy's foot, and this is the tissue of the guy's foot underneath. We're going to look at this in a microscope, a bunch of different things, because you can't get a good feel for something until you really look at it deeply and take some time to look at it. Let me see something. Maybe I can bring out the shadows in that toe here. I mean this foot. See the bones, maybe not. This is hard. Sometimes I could see them sometimes just as easy as looking at my own toes. Sometimes I can't get it to focus in on the right way. But anyway, this was a foot. As are the other ones. The other two I'm going to show you. One of the Oompa Loompa, that's just the weirdest thing you ever saw. Okay, I'm sure I've shown you the lung that still has the coating on it with the spur lock and all that business. Now, that blood literally came out from this lung. Now, this lung has no more pleura on it. It's eroded all the way down to where the alveoli is. Now, you say, well, Roger, why are these not holes like the other lung I showed you? Hold on, the other lung is like this one, like this here. Why didn't they empty out? Well, this was in a different condition where silicates, silicon dioxide, filled these holes. Veins, where blood is, it fills in. Veins and arteries, they fill in. That's why they say veins of gold, veins of quartz. Well, gold actually collects in these quartz veins because it's in the blood. Now, what do we have here? Blood. That's actually blood that came out of that lung, the one I'm showing, not this one. Although I could get a blood out of here as much as I want if I want to break in here and let it saturate out. You know, in certain conditions. This one here, petrified. I can't tell you exactly what the conditions were, but I can tell you what. It wasn't extremely salty, and it wasn't an extremely long duration of being wet. and it appears to have just laid on the top of the ground and dried out. And when it did, it was stabilized. Now, it must have been, hearts and lungs, they have a lot of blood. Blood has a lot of the chemistry that allows for stabilization, what's called nucleophilic substitution. And that's why the hearts and lungs and all that stuff, the bloody stuff, can preserve extremely well. But it has to be in the right conditions. You can't be in salty this and long duration with this and soaking forever in swamps and so. That stuff causes this infiltration, which this is what happened to this lung here. You see it? These are actually alveoli holes. They would have been round like that, only like empty. Or as the water and so forth kept percolating through here, it started to grow crystals in these cavities. Now the blood stayed in here to some degree. This must have been twisted this way, so this was up in the air. I would imagine, I don't know. And this collected somewhere down on the mud. You see there? There's a spurlock. It's got the same thing as the other one, only this one's all eroded out. But that's that little latch. The same as the latch on any meat. You see that? That's the latch. And I talked to doctors and anatomists. They had no clue about that thing. They just said that it's all interstitial. It's just all there. And they didn't realize it was a system and an organ that coats the entire body. And it's all latched together through these spurlocks. All right, don't forget now, this is the really quartz-sided foot that was in some kind of chemistry and some kind of long-duration soaking, which created silicon dioxide, which is sand. Basically turned it into sandstone. Now, that is where the bone of the fibula would have, and this is the lock, and that's the spur lock right there, as far as I'm concerned. And again, maybe you can see it. Whoops. I think I can see it. That round, hold on, let me turn on this light over here. This is the key. You have to have the right light to see things in the right way. And I still can't do it. Usually I can see this just as clear as, well, there it is right there. For me, I could see it right there. There's one bone. And the other one was right over here. Oops. Let me see if you can, I'm going to keep moving this around. If you could play back at it and look here and there and see if you can catch it in the right light. But this is where the blood supply came down to feed these. There's that bone right there. There's a big bone that comes down. This was where the fibula came down, fibula came down to lock on the side, and it just sort of eroded away. Now the other ones completely fell off, like this one here. This is basically the same. It may be the same kind of foot. But this one, this instead of laying down here and eroding away, because this one died on laying flat on this side. You see this? That, there's no question about it. You see how flat that is? This one died like this. So this stayed fairly well intact. Now this one, I believe, I don't know how it died. It looks like it might have died like this. But whatever, it fell off. The whole thing fell off. Just like the other one, the Oompa Loompa fell off too. Now this is where the springs are. This is a no-toe, which is, this is probably also a no-toe. And Tish also, Tish Egerton, I'm going to show you her stuff. Hers are no-toes too. And they also have these latch areas. You see them? That almost looks like a medallion. When I first saw it, I said, holy smokes, this guy had a shoe on. But it's not. That's a pin holding that piece of fabric together against these. They sew into each other, and they sew in everywhere, all over the places. These different layers literally sew into each other. Now, I don't know whether that just split open or whether they seal together, but you see that? I imagine at one time that was a seam. It's not just scratched, because I have bones here. And I know I showed you this before, I think, but same thing here. You see how that has that seam? Wraps right around it. And the ancients used to call this tunica, which is the membrane. You see the membrane seams? And they seem to latch right into each other. And everyone I have has the same sort of thing. They have some fabric that's interlaced into another fabric. All right, you want to see something? This is just too cool. This was completely covered with the fabric. That one's completely devoid of the fabric. And this has some of both. You see this? This stuff is really heavy duty. You see how thick this stuff is? They call that pleura. And that's so your lung can do this all day long. This is the spur lock. There's the fabric lock. The same as the one on here. Same thing. Only this one here has eroded down. Again, it's flat as a pancake on the back. Absolutely flat. These were laying on the top of the ground. This was the conditions where I am. This is my property. I just went out and picked these up. I didn't do any big excavating. I didn't do any special searching here. They just were there. And I mean big ones. And then when I started looking into it and started doing some really research on it and get some microscopes and, you know, a little bit of chemistry here and there and understanding all the anatomy and the fabrics and collagens and the things that make up your body and the anatomy, and here we are. Now, for today I'm going to leave it at this. I'm showing you new species. We have new species that nobody can deny. I have never had one single question, not a single question, from anybody in anywhere, as I said, from all the universities, and I've tried them all. So I wrote this book because Velikovsky wrote a book called Worlds in Collision. And they forced him to take it off the bookshelves after being on the bestseller list for 11 weeks in a row because the publisher was so pissed off. I mean, not the publisher, the academics. They went against the publisher and said, we'll never buy any more books from you if you don't stop the public, take it off the bookshelves. They book burned it. So that's always been really a sore spot in my thinking. So I wrote this book called Mudfossils and Velikovsky, Minds in Collision. Their minds are destroyed, and they will not allow truth. It goes against what they have dictated you must say is truth. This is just not right at all. And if you have any guts at all, you're going to go to your professors and you're going to say, what is going on? What does this guy got? Is he just crazy? And get him to answer you. Don't say, oh, because he's going to say, oh, the guy's just crazy, he's a nutcase, just forget about him. That's exactly what he will be told. Now, do you feel free enough to confront that and say, I don't know, I don't think so. The guy's got DNA, he's got CAT scans, he's got this, he's got that. And not one single response other than don't talk to me again, stay away. Even I contacted Stonehenge. They did respond. They said, don't ever contact us again. I said, your heel stone is a foot. This is what I contacted about. This heel stone is way down away from the main body of the giant memorial of a giant. You see that flat spot? This died in the same flood my guy died in. Now, my big one is probably very similar to this size. And that is the blood from the vein, more than likely, and it probably had the artery here somewhere. You'd be able to find it. This is where all that blood starts to flow into the terminals of the toes. You see that little spot and that spot and that spot and that spot. Those are the terminals at the end of your of your tips of your fingers and your toes, where it goes from the vein, from the artery, and gets sucked back up in the vein. I try to explain. Anybody can go out and see this, and I can tell you exactly how to look and find out, to see the grip skin and to see all of the different types of anatomy here. And I found, whether it is fingertips, there's all kinds of stuff here at Stonehenge, and they said don't ever contact us again. That was it. All right, check this out. Tish Egerton found these no-toes all over the place. I think she's in Missouri, and they have these springs in them. And there's like a plate, and then there's a bloody spot, and this is the architecture. Now, she's got a batch of these. Hold on. All right, this is the heel bone, and this is the tendon that comes up to attach to your leg bone, so that it's sort of all one unit. Now, this is from Tish Egerton, and that's where the fibula just fell right off. And this is the toes, and see how they're going to the side? They're not straight out in the front on the no-toes. And this was my no-toe, and then mine fell off, the same thing like that. Now here's the one that shows this structure here, but with springs. It shows the heel with the strap running up to the saddle that held the main bone coming down. But then you got springs here. They're supposed to be bones. Supposed to be bones. They are not bones. You see that? Anybody that understands anatomy or can look at a picture and tell what I just showed you, that strap is broken, and it would have gone right up to the bone that links here. That's the saddle that the bone sat in. And they all have that same saddle. Now, what is this? All these little round-looking, bubbly-looking things just on that strap. Why is that different than this? Should be just a piece of that strap. No. This was under tension. That's under extreme tension. This is what's called a wrinkle zone. When they snap, this part from here up, probably about up here, went that way. But this snaps back, and you get all these wrinkles. That's what, if you look at the top of Devil's Tower, there's a wrinkle zone in it. Atop of all of these, well, not all of them, but most or a lot of them have wrinkle zones. You can see these little ripples coming down, and then they go straight after that. Same thing here, all wrinkly and then straight. Now, what is these? These are the springs. This spring can come this way. You see it? That's what a spring does. This is unloading. It's loading the spring. It's opening up. And it wants to come back to home. It's opening up. Well, this is attached to this whole spring assembly. This comes back. This looks like it can pivot on that pin right there, and it has a wire, and that wire runs up to this pin up here, and I believe that's right. Now, I can't be 100% sure, but I'm pretty sure. And it comes back down to here. Now, there's a cavity here that's just there. Why would that cavity even be there? Well, it's there because this has to pull in. When this twists up, it pulls this. Well, this has to have somewhere to go, and it pulls in here. Now it's spring loaded. So you got a spring, second spring, and it comes back down to flat. It's not the way your foot works. All right, I think I talked about the Oompa Loompa, and this is it right here. Whoa, look at the size of that sucker. Look at how it looks like a balloon foot. And it's got the arch in it, and the heel bone, and all that stuff. And this was where the fibula sat in here. The tibia was here with that cradle in the back, like they all have. Now, it appears to me, and I'm virtually 100% sure, it landed on this side and petrified. Now, why this is so flat, I don't know. But it's got the same fabric looking stuff and the same seams as they all do. And that right there is literally leather. Let's take a look at it under the microscope. Okay, that's the Oompa Loompa foot here. Now, this is in the microscope up here. Now let me get adjusted here, my good friends. Here we go. What are we looking at? That is the fabric of leather, and I can show that quite well. Now let's move the scope around on this leather to a different area where it's eroded enough where you can see the fabric. Hold on. Let me try to home in. This gets a little tricky. Alright, you see the white fabric? Let me find a good spot. Well, you should see. You see all this white fabric, and you see this. Those are fibers. It's eroded, and it's, you know, this damn thing has seen some action. You know, it's been around for a very long time. Now, this looks pretty. You can see the white fabric, which these are all fibers, and those fibers attach to these black balls, which are the anchors in the skin. That's leather. Now let me show you my belt. You see that? That's the back of my belt. These are the same little fibers and all those little black spots. That's leather, my friends. And here is one of the belt loops that shows how the fabric, all these little black balls are entangled with all these little straps. That's why the leather is so flexible and durable. All right, so that's what it is. And every one of them that I showed you has that same fabric. All right, just so you understand, that's the belt, and that's the belt right there under the microscope. All right, that's my no-toe right here. And there it is in the microscope. You see the fibers in there? See the little balls in the fibers? That's what creates leather. All right, check this out. That is that lung. Now, lungs are a little different. They have the same fabric. All of the membranes have the same fabric. It's made out of collagens. The white ones are the stretchy ones. And every fabric has to do some stretching. Very little in bones and so forth, the fabric to coat bones. But in the lung, look at these babies. This thing is just, it's just a big rubber bag. And here's what happens. When you get sick and your lungs start to not work right, these collagens are the ones that get affected. And I believe, I'm not going to go deep into the biology, but what they have to do is to look into what happens to collagens. And the reason the collagens become invaded and affected is because of bacteria. Bacteria create enzymes. Enzymes are catalysts. Catalysts break down chemistry very, very quickly. And so, but you also need bacteria to keep the fabric flexible and working correctly. So it's a fight between the two bacteria. Anyway, that's a whole nother issue. But what you should do is start talking to your professors and so forth and say, look, I want some answers. Why is this not being looked at? Again, not one single question from not one single university. And I went to everyone, Yale, Harvard. I even took a course at Johns Hopkins for genomics to talk to the professor about the DNA reports and all that. That didn't work out. University of Texas was an absolute nightmare. And I mean a nightmare. That involved authorities on every level. Anyway, it's just crazy, absolutely insane. If you want to walk around in circles and deny your past and your history and anatomy and chemistry and geology and biology, then you're just walking around in circles. Now don't forget, this is a brand new species of these no-toes with the springs inside. This right here is that spot I said in the tendon that gets all wrinkly, and this isn't. Now this was the spot I just showed you that straps around and latches up to here. I don't know what's going on with that. But that ran up to the bone that would have been in this saddle right here. And that strap ran up to that bone. Now, let's look real close at that wrinkle zone. All right, but you can see there's all kinds of biology here. This is not just an accidental rock. And that's that really heavy-duty, gnarly spot. Like everybody has one on their feet. All right, Alright, watch this carefully. Here's what we're going to do. That is that gnarly spot. That is the round spot that ran up to that latch. And we're going to view this. I'm going to go depth, coming up. Now we're looking up here. And now we're going to be looking up to where that tendon glues in there. Alright? That's where the tendon actually glues in. Now I'm going to point down below to where we're actually looking at. And there it is right there. This is the spot we're looking at up above in the microscope right now. And then it transitions into this white. Alright, look at it carefully, because here's what it looks like in the microscope. You see it transition into the white, the same comes off this way. Now this is tendon. That was glue. This is tendon. And the glue glues it so that it can stretch. And it won't pull off of there. Now, let's go up that tendon strap. That strap. Now remember I told you this is the wrinkle zone? There it is right there. That's the wrinkle zone. That's where it's snapped back, and I might be able to get a little better shot of that. But that's what a wrinkle zone is. It might not make sense to you, but it does to me. That should have been white like that and flat all the way out. But when it broke up at the top, that's when you get that wrinkle zone. Alright, now that would have run all the way up the guy's leg, up to this saddle, which is up at the end. Maybe it shows back up here a little bit. But that's where the saddle is at the end. You see? Very complicated device. Look, I don't know what all these little attachments are and so forth, but these are within the foot. And every one of these separation areas means that there's some kind of different chemistry going on there. And that I know is a tendon, abrupt transition of a tendon from, this is the latch. And these are little tendonish spots that run to that circular thing that ran all the way around. Remember, that ran all the way around. And down here, it almost looks like it's got a springiness of it. You see, it looks like, to me, let's get in real close on that. Hold on. When you get in close, it gets confusing. I don't know. There's all kinds of things going on here. That's kind of interesting. But that's the tendon right there. And then here's the wrinkle zone. That's where the wrinkle zone starts. See, these were little stretchy fibers. Cling! Same thing on Devil's Tower. You look at the top of Devil's Tower, same thing. Okay, I told you there was a bone right there, and there is. That was a bone, and and that was sitting in that cradle. Now, in addition to that, there was another bone back here. You see this? Blood comes running down into your leg, from your leg down into your feet. And that's where plants grow, in that blood. It's just, and this has been in my shop 10 years. So they can live in rock. And that's why you find them in the craziest little rock spots. Let me show you Devil's Tower. Alright, what you're going to see at Devil's Tower is that. This is what happens. They get a wrinkle zone, and then it comes down and it bulbs around, and then you get a wrap around the back. And there has to be some little bits of blood supply that run up to service these tendons. Very little. Very, very, very little blood supply. All this stuff is gone. That's eroded away. And again, this is all we have at Devil's Tower is just this and that little stalk sticking up. And the wrinkle zone. You see that? That was a foot. It's exactly what I just showed you. All these are little tendon fibrils. And this is the wrinkle zone at the top. Where these little things are growing, there was blood there. Same thing here. There was blood. These are little blood vessels that all came around here to service that tissue. And now there's plants found that blood to grow in, and they like it there. Okay, so my friends, I think I've shown pretty well what we've got going on here. And there was giants in the earth, just like it said in the ancient texts. And I'm not any big religious fanatic. I'm just an honest person, and I find what I find is honest. Now, research, and I'm a researcher. I'm a material researcher. Not a word I have said about here is just speculation. So, research requires discussion. All right. Again, it's over 10 years that I've had all this evidence and been presenting it to virtually every academic institution, directly to the people that are making the statements, and they still make the same statements, and they refuse to engage. So peer review must include willingness to engage. How can they peer review somebody? They say, oh, the guy's crazy, just leave him alone, stay away from him. This is my address, Roger at Mudfossils, with an S, .com. Refusal to engage disqualifies any, what they would call a scientist. If you're a scientist, and Einstein said it too, he said, refusal to engage disqualifies you. You're not a scientist. They just become irrelevant. So, if you talk to your professors and your peers, after seeing what I showed you, and you can just walk away from it and not engage your peers, well, I don't have much respect for you as a scientist, certainly, or as an honest person. Because we've been told things that just aren't right. And I'm just trying to set the record straight, that's all. I'm not trying to damage anybody's reputation or anything. It requires just being open and honest, that's all. Fair, open, and honest.